Hello and welcome to another video. Today we have an B650 Eagle AX on our bench. This came from a viewer. Hello Mainboard Medic. I recently planned an AM5 upgrade since I wanted to finally retire my old 4770K great CPU back in the day. With a switch to Windows 11, I decided to go for the B650 Eagle AX along with the matching CPU. Unfortunately, while installing the CPU, I accidentally slipped into the socket and bent several pins. On top of that, the top clip of the PCIe slot is missing. I have no idea how that happened. I really hope you might be able to help me out. I really enjoy watching your videos. They are always entertaining, educational and super helpful. Keep up the amazing work. Many thanks in advance. Best regards, Niklas. Well done. Let's see if we can help Niklas. Let's open this board up and see if we can bend pins back into place. I got to be honest, I really do not like repairs regarding like bent pins or sockets or similar things, but they have to be done, especially on these AM5 boards. They can save a great board just by bending some pins back. And yeah, but socket swaps are not in yet for me. That's something for the future I want to learn, but yeah, I haven't gotten to that yet. But let me first thank today's sponsor, which is PCBWay. I love PCBWay, the way they, the work that they do. They helped me greatly to design one of these. These are designed by myself, and with the help of PCBWay, I was able to make these PCBs that are inside of there. And I've done different PCBs as well. I've done a switch panel box like this one. There's a big PCB that takes breakout boards that break out to different things like USB, like a barrel jack, like a fan connector, and only takes a 24 pin right here, and there's the PCB inside. And yeah, on my electronic journey, they have been great with supporting this channel and our ways, so thank you very much for them. They also do more like 3D printing, sheet metal fabrication and similar stuff. So if you're interested in any of that or want to make your own electronic devices, go check out PCBWay. So with our sponsor spot done, let's go under the microscope. I think that's the most reasonable thing to just instantly have a look at the socket now. So I can see some thermal paste. Let's first get rid of that gooey thermal paste, but yeah, I got it all of my fingers, of course. But this doesn't matter, this little bit right here. So let's see, there's more thermal paste I can already see. So thermal paste in a socket often isn't even a problem, to be honest. Like very often the pins make good contact anyways. So very often people try to clean off thermal paste and they break more than they do good. But because we are here already, we're going to take off as much as we can without disturbing the pins too much. Let's clean off the tip of the tweezers. So a little bit more clean tweezers. And with that, the thermal paste is mostly away from the pins, which is the most important thing. Like the top of the pins are clear now. So all of this can be left like that. And the only pins that I can see that have trouble are around here. So there's a few pins that are just ever so slightly bent here, but they're very little, to be honest. I don't think that this will cause a board not to work. Like this one is a little bit to the side, but like so minimally. Let's see, like this. Like this, you can see very, very well 3 pins that reflect the light a little bit differently. Like this one, and this one. But they're so minimally bent that really it shouldn't matter, to be honest. Yeah, I wouldn't even touch the socket anymore. Because the rest of the socket looks quite fine. I want to show you how I always look at that. For that we need to go to the overhead camera. So you need some light and you need to twist the board around like that. And by the reflection of the pins, you can see if any are off. And they look really fine now. Like there's a little bit what you can see on the left right there, which is still thermal paste. That's why there's a different kind of reflection there. But there are no bent pins anymore. The area that we worked on was right here in the middle, and there's nothing anymore. But I got to say, I doubt that that was actually the issue, to be perfectly honest. Because that was so minor that I cannot believe that that has prevented the board from working. So I would expect there might be even further faults on here. But to check that, before we do anything with this board, let's see for some resistances, because there might be something else wrong with this. So let's check the 12 volts. 12 volts is fine. 12 volts into the phase is fine. Then let's go further and let's check then the 3.3 volts. 3.3 volts has 440 ohms. That could be fine. 5 VSB has 1 kilo ohm. The 12 volts has kilo ohms and rising, and the 5 volts has kilo ohms. Okay. So this looks so fine so far. Let's check the BIOS battery. BIOS battery has 3.1 volts, so that looks fine. Let's check some inductors that I can see here. So inductor right here, 700 ohms, another inductor for kilo ohms. Then there's inductors for the DDR, kilo ohms, another big one here. Also kilo ohms, another voltage regulator, kilo ohms, another regulator here. This might be, no, it's not the PCH 1 kilo ohm. Okay, so far this looks very good. There's obviously still the latch missing, but I would want to go ahead and see for how this board behaves. So let me get a test processor in here, and we're going to find out. So getting out my trusty old 7500X. So let's get the CPU installed in here. So CPU is in well. Let's get the power supply connected. And I got to be honest, I expect this to boot if there's not anything else wrong with this board. If it's like, if it was only those pins that we saw, I would expect this board now to work. But we will see. Let's get a speaker onto here. And we need a power button. Let's get one stick of DDR5 RAM. And let's now together see what the passive power consumption of this will be. 125 milliamps. That looks very fine. Okay, I think I should get a cooler onto here. So we have debug LEDs right here. Top left CPU, top right DRAM, bottom left VGA, bottom right boot. So let's hit it. CPU to VGA to DRAM. That looks very good. And now probably because AM5 it takes a long time to RAM train. Now it will probably take a long time on DRAM. Let's see, we have 3.6 amps, VGA. Do we get a post screen? A post beep? Let's see. We still at VGA. And there's a post screen. Wow, that was, I gotta say, that was easy. Like, that wasn't hard at all to do. Wow, okay. Well then. Yeah, I didn't have to do much here. Let's test some more RAM in here. I do have 2 more sticks. I'm missing a 4th one, and yeah, with the current prices of RAM, I do not want to get another one. But yeah, let's at least try with a little bit more RAM. It might not boot now because these are very mismatched. And yeah, and AM5 is very picky about RAM. And I want to see for if this can go into Windows also. So if we can actually boot. So let's see right here. I actually got more RAM into here now. And I got a GPU into here and an M.2 in order to see if this will go into Windows. So let's hit the power button again. It instantly goes from a CPU to a DRAM LED. So I got to say, these bent pins really weren't bad. Like, I've seen so much worse. There wasn't a single pin broken off. There wasn't any pins, like, completely bent into the other direction. This was, like, very minimal. Just a little bit thermal paste as well that I had to clean off. And yeah, this was so far a quite easy one, I gotta say. And it instantly booted up. Let's see now with more RAM, because broken pins and sockets can very often lead to RAM not being initialized or not being detected because of data lines missing. But in this case, I think we're very fine. The power consumption is jumping a lot around, and we're stuck on a DRAM LED, but that is probably because of RAM training. Because RAM training on AM5 always takes a lot of time, and it might not even post because it's not happy about the RAM configuration. As I said, this is a very scrambled way of adding memory to this, and AM5 can be very picky about cheap DDR5 sticks, especially if you mismatch them like I did here. And I think currently it does not like the RAM that I'm using. Because now we're stuck at 2.4 amps. Let's turn this off and on once more in order to see if it... No, let's replug all of them, because they lay around at my place for a long time before they get used. So I'm just opening and closing the socket properly on all of them. So let's try that again with all the ones replugged in. And it's so great to see the power consumption of this, because with the 2.8 amps you can see if actually anything is changing. Now we go to almost 3 amps, that means something's changed. Back to 2.8, let's see if it goes down to like 2.4, 2.9 again, 3 amps, okay, 2.8 amps. So this really shows you 2.7 that there's something happening on the spot. It isn't just stuck currently. Let's see if it goes further now. 2.8 back up to 2.4, and now it's probably stuck at 2.4 and not going anywhere anymore. Yep, and now it's stuck at 2.4. Okay, so I will have to do a little bit of different RAM configuration. So what would be interesting to know first is every single stick works individually. So let's try that first. We had a boot in the second to the left one. I will use that stick of RAM now, and let's now try this in the different slots and see if it boots with a single stick in every slot. And if it does that, then we know it's just a memory configuration error that I have here. So I'm currently fighting a little bit with the board. I got boot out of the second stick. I got boot out of like the second slot. I got boot out of the fourth one, and now I'm going to try the first and the third one. So I'm struggling to get a post out of the pin out of the first and the third socket. So out of A1 and B1, I'm struggling to get a post out of. It might be that A2 and B2 first need to be occupied, and that's why it doesn't want to work. But I had a look around the board just to see if anything is knocked off, and to have a look what I saw under the microscope. Like, have a good look at this chip. Doesn't this chip look like it's been reworked before? Like, can you see that side of those pins? Doesn't that look like it's been reworked before? That is very weird. I wasn't told that this had any prior work done to it. And yeah, that is very weird. I will be still trying to get see about the configuration of RAM if I'm doing something wrong, and that is why, or if there's actually something broken here. So give me a second. So after a lot of testing back and forth, I cannot get a boot out of this thing as soon as I populate 1 and 3, so corresponding to A1 and B1. Those channels are not working. The important channels of A2 and B2 are working, but yeah, as soon as you want to plug more than 2 sticks of RAM into here, this board won't do currently. So we need to see if this has like damage on the backside of the board. maybe scratch traces or anything. And if I can't find anything like that, we need to see for broken off components for like around the VREF circuit. And at the end, check the socket again, reseat the CPU. I might just clean my CPU and reseat it first, just to be sure that that isn't a problem, because I've spent like 50-20 minutes cleaning out the sockets of the RAM just to be sure that that isn't a problem, because currently I actually cannot get a boot. So let me reseat the CPU a couple of times and actually clean the bottom side of the CPU in order to figure out if that can already solve our problem here. So all I do is just carefully take out the CPU now, and let's then take just my nano sponges that I always use, drown these in IPA, and just clean the backside of this board, of this CPU. And like, you kind of want to even polish them, even if they don't have anything, any dirt on them. You want to get them nice and shiny. And after I'm done with the nano sponge, I'm going to take a clean cloth and I'm just going to rub it a lot over it to polish it, just to make sure that these can make the best contact. So, and after having it cleaned, let's reseat this CPU. And what we can also do, we can apply pressure and open this socket a few times. And this can also help with making contact in the socket again. So let's hope that this is already that this already solves our problem. So by only reseating the CPU and cleaning it from the bottom side, let's see if this can get a boot for us now with the other sticks of RAM. And no, that didn't help our boot. Okay, so let's attend the backside of the board then, in order to see if there's anything damaged there, because the board does not want to boot with those memory slots occupied. So, time for some good old visual inspection. So, what we can also check first. Let's go around the CPU socket and check if we have anything damaged here. So, if you can see some obvious either components or like tracks that are broken, especially around the mounting holes we want to have a look at. So far, so good. Looks very clean. Yeah. And there's no obvious damage on the front side of the board. Let's go around the DDR sockets. Have a look here. If we can see anything. Let's see in between these sockets, but like in between the sockets, I've never seen anything broken there because it's very hard to reach. Yeah, it looks very fine. Except this chip, like we said before, that looks reworked. Yeah, but the rest of the board on this side looks very clean. So let's flip it over and have a good look there, what we can find. So underside of the CPU socket, these are some PCIe capacitors. They all look fine. Let's see closer to the socket. Some resistors directly under the socket, only capacitors. All look fine. The VRM phase. I wouldn't expect there to be anything with the VRM phase because, yeah, the board is booting and there's no problem with that. Just want to see if there's like any broken tracks anywhere. But it's looking very, very fine, all of this here. See for these components up here. Also no problems at all. And yeah, it looks very clean. And the big thing here is actually that this board actually has SMD soldered RAM sockets. So none of these are through hole except like the mounting holes here. And all of the rest is SMD. So that is actually very interesting to know. Let's see some more behind the chipset if there's anything broken here. but also looks fine. So we will probably have to take a good look from the top side of the board, because that's the only path where traces can take in order to get to the sockets. Because the RAM is like really, these are high frequency signals. They try to take a very short path, so they should be from the front side, but I cannot also see them from the front. Do they really run inside of a layer? So this is actually a very hard issue then to figure out, because as you can see, these are the pins, and they all look to be very fine. I don't think that this component was ever fitted. Yeah, the soldering like looks immaculate. And the big problem is we cannot really see the soldering in between. Like if we try to see the ones in between the socket, like to look right here, this is kind of difficult. And we can see parts of it definitely. Yeah, but I cannot reach it with my tweezers to like wiggle it. Like they really don't look perfectly on here. Like if you see for that one, for example, it kind of looks like it is shifted. And that one kind of doesn't look like it's soldered at all. The one right there. Right. Oh, I cannot reach it. This is such a confined space right there, but it is soldered. Yeah. And that one also. So they are all soldered, even though some of these don't look quite right. So I'm slowly running out of options here. Let's just investigate these sockets by themselves, but it also they all look clean, like there's nothing here. Like you can see, like it's a little bit dirty in there, but I've cleaned them out a lot. I wouldn't expect anything of this to be still an issue. Difficult case, difficult one. So I've actually spent quite some time now on the board. I've actually flashed the BIOS also, just to be sure that that isn't the case. And after all of trying, the only thing left now is to have a good look at the CPU socket once again. So something must still not be right. Some of the pins will be for the other RAM sockets, and we have to try to find out which ones of these now still make problems. This is still the one where we had like thermal paste, but I got to say, this is like where the thermal paste is. I don't expect anything of this to make a problem, because the heads of them all look clean. So I don't think any of these will be our actual problem. The actual problem will probably be somewhere around these ones right here. Big question now is which of these actually make problems, because there's a little bit of thermal paste right here, but I don't think that this does problem. Yeah, this is just very little thermal paste again, and I don't think that that makes a problem. The bigger problems will probably be this one. I want to bend this one further back. And yeah, because when you move them back, as soon as you first plug a CPU into there again, they will, the CPU will bend them down back as far as they need to be bent. So sometimes it's just that you have to take these and bend them a little bit backwards. Because the most probable is that it's some of these pins that don't make proper connection in order for us to have boot out of the RAM sticks, because these are closer to the right of the socket. In this direction the RAM socket sits, and that's why it's probably more realistic that these are responsible for the board not booting. Let's get a different view onto them in order to check again. So I gotta say, it looks so clean. Like, if there's any irregularities, you would be able to see them, but like, I cannot see any irregularities via the microscope. A little bit right here in the middle, but it looks so fine. Like, oh, so there's really nothing to be seen anymore. I will clean up a little bit of this thermal paste that is all around the socket because there's a lot of it, but I don't think that there's anything else wrong now. Like, looks so clean. Let me clean off a little bit of this thermal paste, and then I will try to reseat this and see if we can get a boot now. So let's take a look at a data line tester for DDR5. And it looks like there's some missing, like you could see right there, but they're just very dim. And while looking at this, only the ones that I've marked are not lighting up. And this is the working channel. And now going into like the first one, that is a not working channel. If you go into here, it looks exactly the same. So all of the data lines are connected, which would lead me to believe that the socket isn't the problem anymore and that there's something else damaged here. Something regarding the other two slots is damaged, and I currently cannot figure out what it is. And I will have to invest quite more time in order to figure out what it could be. Like if there's any damage anywhere. Because the data lines to the CPU are all good. There has to be something else, like a VREF or something like that has to be damaged, which does not then go to these two sockets. Like, I don't have too much experience in AM5 in DDR5 problems, and I will have to educate myself a little bit in that and what it could be. So I'm fiddling around with this for quite some time now, and I went into the manual for this board for installing the memory, and they recommend to never populate 3 modules. They only recommend 1, 2, or 4. And they start with A2 and B2, obviously. 1 module to get into there. And after having A2 and B2, they never go to 3 modules, only to 4 modules ever. To then have all of them occupied. And they specifically state, when installing memory modules, be sure to install DDR A2 socket first. And with A2 it does work, and with B2 it does work. But as soon as you try B1 and A1, it doesn't work anymore. They continue to say the motherboard provides 4 sockets and support dual channel technology. After the memory is installed, the BIOS will automatically detect the specifications and capacity of the memory. Enable dual channel memory mode will double the original memory bandwidth. We might want to disable that. The 4 memory sockets are divided into 2 channels. Each channel has memory sockets as following. A1, A2 is channel A, and only A2 is working, and channel B, only B2 is working. Due to CPU limitations, read the following guidelines before installing the memory in dual channel mode. Dual channel mode cannot be enabled if only 1 memory module is installed, which we will have if we have 3. When enabling dual channel mode with 2 or 4 memory modules, it is recommended that memory of the same capacity, brand, speed, and chips to be used. So what I want to do, I want to see if I can disable dual channel mode in the BIOS and then try 3 sticks of RAM. I wouldn't think that 3 sticks of RAM or just a single stick in B1 or A1 would lead to this board not working, but I cannot find anything else regarding the RAM sockets for why they wouldn't work. So let me see if there's an option to disable dual channel mode for the memory, and then see if I can boot with 3 sticks of RAM. So I did some checking, and there is no option. Like, I've tried to disable a lot of these things that, like, for boosting memory and stuff like that, and there was no way to disable the dual channel on this board. And yeah, I'm kind of running out of things currently, what to look for and what to do, to be perfectly honest. I started to have a look at how these are connected. So I have a board for this board. And what I did is I would go around, like, click through each individual signal and see what they're connected to. So the first two ones are just DDR 5V dual, and they are connected all the same. All are connected together. So because the other twos are working, I cannot believe that there's no reason why this shouldn't work then. Like, if it works for one, it should work for all because they're all connected to each other. Then there's SMB, clock, and data. And they also all connect to the same points and are connected within each other. And then it starts for the data lines. But these data lines, we've checked with the data line tester, and they looked fine. And the thing is that they are always connected with A1 and A2 together. And A2 is working, but A1 isn't. But like this, you can see they are only connected to these 3 points, and all of these data lines then go to the CPU socket. In this case, they start from the top there, and then it just continues with ground data, ground data, ground data a lot, back and forth, and it's always the same, always two connected in the RAM sockets, and then connected to the CPU. And this goes on and on and on until you have something that is CS0. This is probably something like a chip select, but that is just a single pin right there connected with this DIMM. So if the socket is fine, this DIMM will also be fine. And then going further, just some more command lines. And all of these have the same like the data lines. And then there's 2 other lines right here that are only connected to their CLK0 that are connected to these 2. So only checking the socket again, because there's nothing else connected in between. There's more here. And then again, going back to data connections, another CS0 that is connected right here. A reset signal that is then connected to both again, so it doesn't matter. And more data lines, command lines, whatever they're called, connected to both of these. And then again, 5V dual, but 5V dual and the 5V power grid is connected to all of them. And then there's a single thing, DIMM1 A1 SHA, that is only connected to a single 10k ohm resistor, and then k ohm resistor just goes to ground. So that's a thing that you could check, but probably it's there and it's fine. And then continuing DDR5 enable for all, and even more data lines connected to both of them. And one more chip select pin that is also on this right one, or probably chip select because it's CS1. And a little bit more of clock pins, also again to the middle, connected to this side of the socket. And another one. So the only thing is some pins around this side of the socket we need to check. But the socket looked so good, like there's nothing I can see anymore. But I want to have a look once more in specifically this area, and we will have a look for that 10k ohm resistor. So one of the few things to check is this single 10k ohm resistor that is everywhere, but they're all fine. They're all connected where they need to be. And I'm really running out of things. Like these sockets, everything around them looks fine, completely fine. Like there is nothing wrong about these. And there's like the clock and data thing right here for the RAM sockets, but yeah, they're responsible for all of them. So I wouldn't expect there to be a problem like that. So, and once more having a look at this right side of this socket, and it looks immaculate. Like, I really cannot see any here that are damaged. Let's switch this around a little bit to see more of these. Like, all of these look perfect. Like, all of this socket looks just immaculate. Like, I could try to, like, clean these up that have a little bit of thermal paste left to them with a very soft brush, but I don't think that will do anything for us here. Like, what you can do, you take IPA, a very soft brush, and go over these pins in the direction that they go. And you can see they're cleaned off now. And yeah, pretty sure that this won't do anything. Yeah, they're totally clean now and there's nothing. So one last thing to do is to actually remove the socket cover completely in order to see if there's anything there. So let me get the correct Torx. I think it is right here. In order to remove this Lotus socket cover. Let's take this carefully off. And I cannot see any problems at all. It all looks completely fine. Let's go under the microscope again. So now we can actually see some wires going off of the CPU socket. But they all seem to travel into the board that go to the memory. Yep. And there's nothing damaged, nowhere. It's all just clean. And they've moved away from routing the data lines on the top layer and they're routing it on a inner layer now. And yeah, like there's a few pins that in the reflection still look like they're a little bit misaligned, like not perfectly like the others, but it is so minimally that I cannot imagine that to be our problem here. And I like against the light, I can see that this one is a little bit to a different side, but looking under the microscope, there's nothing with them. Like, yeah, I can see that little bit of thermal paste there, but that is nothing. Yeah, there's just nothing for me to do here. Let me check the backside where we taken off the CPU bracket for holding the socket in, but this is also very clean. Like these are all PCIe signals as far as I know. These don't go to the memory because they all go down from the socket. And everything here looks immaculate. Like not a single scratch, nothing. So what makes me so skeptical about this board is that I feel like with a single stick in A1 or B1, it should still work. I know it's not the recommended, like recommended memory configuration, but I feel like it still should work in A1 and B1, just putting a single stick into there. Like, I cannot believe that you cannot put like 3 DIMMs into here, that it's only possible to use 1, 2, or 4. And when you're using 1 or 2, only go A2 and B2 and not A1 and B1. It's just, I cannot believe that is the actual issue, but I cannot find anything else. Like, I cannot find any knocked off components. I cannot find any more broken CPU pins. I cannot find any broken data lines. All of the data lines looked fine. The BIOS is flashed. Like, I do not know where to go from this. If this is actually a fault, this might be a fault that I'm chasing that is not there. Because A2 and B2 work perfectly fine. Oh man, this annoys me a lot. I just don't have 4 DIMMs of DDR5 RAM. I might have to look very close on like the local cracks list that we have, like something like that, to find if I can find like 2 more sticks or a single stick of DDR5 RAM that I can quickly throw into this to test this out. But yeah, for now, I will leave it like this. I will see if I can get some RAM. So sadly, this video is very inconclusive because I had a talk with the owner and he said he will only be using A2 and B2, which means he only has 2 sticks of RAM, and that way it's fine for him. I gotta be honest, I think why I cannot get 3 sticks of RAM working in here is only because it's not meant for that memory configuration. I don't think there's anything wrong with this. Like I've showed you in the manual, it only recommends 1, 2, or 4 module operation. It never talks about having 3 DIMMs, like I try right here. But what is very weird to me, that the configuration doesn't work at all if you only use a single module in A1 and B1. I've never seen that before, that it doesn't work like that. I always know that you have to go A2, B2 first, but I've never seen it that it does not want to post at all if you go A1 and B1. But yeah, sadly, a single stick of RAM currently is 80 bucks here in Germany, because you've probably noticed the RAM pricing, and I'm not going to pay that much money to get another 4 sticks of RAM for this board just to test that out. And as I said, the viewer is very happy that the board is working and functioning properly now with only A2 and B2, because that's all he has anyways. And yeah, so with that, sadly kind of inconclusive, but we were able to do a lot of testing and looking around for what could be the problem for DDR5 in this case. Hope you still enjoyed it and learned something. And one more thing that we can quickly do is he asked me to swap out the clip for the PCIe. So we're just going to take, let's take, which one are we going to? We're going to take the lowest one. We're going to put it in the upper slot. So pry out the one from the lowest one and put it into the top slot, so that he has a PCIe latch in the top one again. And yeah, with that done again, I want to thank once more PCBWay for sponsoring this video, for all of that, what they make possible for us to make our own electronics. And I hope you learned something. I hope you enjoyed this video anyways, even though it's kind of inconclusive. All of my tools, as always, are linked in the video description. If you want to get one of these current measuring devices for yourselves, email me. And yeah, this was Mainboard Medic. Thank you very much, and goodbye.